Okay, so we're looking at two different functions here, and we want to find each of the function operations. So remember that's addition, subtraction, multiplication, and division. So let's just go through those in order. Let's start with multiplication. So if we wanted to find f plus g of x, remember that that was defined as f of x plus g of x. So in this case, if we wanted to find that, we just have to plug those two things in. So f of x is x squared plus 1 plus g of x is 3x plus 5. And at this point, it just becomes, can we find like terms? Well, the only like terms I see are the 1 and the 5, so x squared plus 3x plus 6. F plus g of x. Okay, so we can do something similar for their difference. That's f minus g of x. So again, that's defined as f of x minus g of x. Now you don't necessarily have to write these extra parts out, but sometimes I think it's helpful, especially when you're subtracting, and well, depends on how you see the operations, but especially when you're subtracting, because then it allows you to see that subtraction symbol. So as we write x squared plus 1, remember we're subtracting the group of 3x plus 5. So we actually have to distribute that negative. So x squared plus 1 minus 3x minus 5. Again, we still have like terms, and we end up with f minus g of x is x squared minus 3x minus 4. So it's slightly different. It's not exactly the same, but they behave kind of similar to each other. If we were to multiply these, so if we wanted f times g of x, well, again, by definition, this is just f of x times g of x. So we just multiply these two together. So for us, that's x squared plus 1 times 3x plus 5. And a lot of times we do just multiply this out. In this case, this is foiling. So x squared times 3x cubed, x squared times 5, 1 times 3x, and 5. We don't have any like terms here, so this is just f times g of x. And I'll caution you not to write multiplication as an x, because f times g of x is actually pretty confusing notation. So don't use that symbol in the middle. It makes it kind of awkward to read. Okay, last but not least, we have our division, f over g of x. And again, that's just defined as f of x over g of x. And we need to be really careful that g of x is not equal to 0 for this new function that we're creating. Okay, so when we do this, our numerator function is just that x squared plus 1. Our denominator function is that 3x plus 5. It's not common for us to be able to simplify this more. It's always a good idea to just check, but I'd say 9 out of 10 times, there's not much more you can do beyond this. So f over g of x. And we just want to acknowledge that that 3x plus 5, that's g of x, right, cannot be 0. So that's 3x not equal to negative 5, x not equal to negative 5 thirds. So we just want to acknowledge this because it is a domain thing. Okay. So these four functions that we just wrote out, the blue, the purple, the green, and the pink, all four of those are actually brand new functions in and of themselves. They should all pass the vertical line test. They should all they'll all have domains that we can look at. They'll inherit function properties, and you could add or subtract or multiply or divide any of these two as well and do exactly what we just did. I can't promise it's convenient, but we could do that. The other thing that we can do is we can find function values. So what if we were to find f plus g of 1? Well, we've found function values in the past, right? I'll write out the function we got. It was our answer from up here. So this was x squared plus 3x plus 6. And let me put a x here for a moment, so it's a little more accurate. So of x. And we're going to find, let's say, at x is equal to 1. So the same as f plus g of 1. Well, all you would do, and again, it's what you would have done with any other function, right? F plus g of 1, you just plug it in. So 1 squared, 3 times 1 plus 6, so that's 1 plus 3 plus 6, and that gives you 10. So this is a function value, and this means that if you wanted to graph this, you would graph the point 1, 10. And we could do this for any of our functions. We could say find f, let's do over g of 0, right? Well, as long as we have that function, we have it right here, we can plug 0 in, right? So this is 0 squared plus 1 over 3 times 0 plus 5. And we're allowed to plug it in because it's not this value we took out of the domain. We can plug in anything else that we want, right? So 0 squared is just 0. So in the numerator, you've got a 1. 3 times 0 is also 0, so this is 1/5. So again, this gives you the ordered pair 0 and 1/5. Okay? So you could do this with any values. Again, as long as they're in the domain of the functions, you're good to move forward. And we'll talk about domains in just a